Hello. In this video, I'm going to try to teach you about voltage and current, just what these words conceptually mean without any math. So first, let's remember what electricity is. Electricity is the movement of electrons from one place to another place. The kinetic energy the electrons acquire can be taken away and turned into other things like light or heat, or mechanical motion. Now, although negative electrons are actually moving through the circuit, we pretend like there are positive charges moving around instead for historical reasons. So I might say positive charge instead of negative electron, but it doesn't matter. The analysis is the same. First, I want to teach you about what voltage is. Now, a reminder. Objects in a gravity field, like above the planet Earth, they have gravitational potential energy. Remember, mgh, mass, times 10 times the height? And we say that they have this energy because if you let them go, they start moving down. You let them go and they fall. That's why they have potential energy. Similarly, electric charges in an electric field, they have potential energy too. Because if you let go of them, they will move with the field. The same way that if you let go of an apple, it falls down a tree. The voltage at a specific point measures how much energy 1 coulomb of charge would have if you put it there. It's basically the electrical potential energy. So just like real physical objects, I can lift it up in the air, like it has a higher height, and I let it go when it falls. Electrical charges, I can lift them up to a higher voltage, and then if I let them go, they move down the voltage line. We measure it in the unit volts, and 1 volt is 1 joule of energy per coulomb. A high voltage means that electrons have a lot of potential energy, and a low voltage means that electrons do not have a lot of potential energy at that point. So voltage is a lot like gravitational potential energy. Electric objects, they fall from high voltage to low voltage. Just like real objects fall from a high elevation to a low elevation. The thing is, electrical charges, they can fall down in any direction, not just literally down. So gravitational fields, they always point towards the center of the planet, and that's why apples always go down. But electrical fields can point anywhere. And so the electrical charge falls down in whatever direction the voltage points. Well, it doesn't fall down in the direction the voltage points. It falls down from high voltage down to low voltage. This is why electrons move through wires. Just like objects go from high elevation to low elevation, electrons go from high voltage to low voltage, and the positive end is high voltage, and the negative end is low voltage. And they would fall down the middle of the battery. They fall down from the high to the low, but they can't, because the middle of the battery has a barrier that they can't pass. And so in order to fall from high to low voltage, they have to go through this entire wire. So basically, you can imagine that they're falling down, falling down, falling down, falling all the way through. It's a little bit weird, but in principle, it's how it happens. So every single point in the universe has a voltage. Electrical objects want to fall down to the lowest voltage they can. The way that circuits work is they give electrical charges a path from high voltage to low voltage. It's like you have the apple on the tree and it can't fall because you're holding onto it, but then when you attach a wire, you all of a sudden let go. You give it an opportunity to move down that voltage gradient, and it does. So the way that circuits work is they give electrical charges the ability to move down to a lower voltage area. So that's voltage. Now let's go to part 2, current. Current is easier. It's a measurement of the rate of electricity flow. It measures the amount of charge that passes through in a second. So for example, if I had a wire with a low electrical current, you would only have a few electrons moving. They'd be moving slowly. But if you had a wire with a high electrical current, there'd be tons of electrons moving all the time. So current is just a measurement of how many electrons are moving in a second. The current at a specific point tells you how many electrical charges pass through that point in 1 second, and it's measured in the unit ampere. 1 ampere, or 1 amp, is 1 coulomb per second. Part 3, last part of this video, I want to tell you about the voltage difference. So the voltage difference, which is also sometimes known as the voltage drop through a circuit, it measures how much energy a 1 coulomb charge loses when it moves through. Resistors take energy away from charges, so every resistor has a voltage difference. That might seem kind of abstract, so let me give you a decent example. Let's say that I have an electrical charge moving through a resistor. The charge has some energy because it has some voltage, and when it moves through the resistor to the other side, it's going to lose some energy. This specific resistor, which is a 5 volt resistor, will cause 5 joules of energy to leave this charge when it moves through. Now if I had this same resistor, this 5 volt difference, and I put 2 coulombs of charge through, what would happen is every single one would lose 5 volts. So for this resistor that has a 5 volt difference, every single charge loses 5 volts. So I had 2 charges, so I lost 10 joules of energy. The part of a circuit that gives energy to a charge is the battery, and the parts of a circuit that remove energy from the charge are called the resistors. So let me give you an example, a specific example of 1 unit of charge moving through this circuit. The charge has no energy, but then it goes into the battery, and then it gets some. Let's say it gets 10 joules of energy. It's a 10 volt battery. So it has 10 joules, and it moves through the circuit. It hits the first resistor. Now this resistor takes some energy away. It takes 2 joules of energy away from it. So we'll say there's 2 volt difference across the resistor. So anyway, it started with 10, it lost 2, now it has 8. So it's going to keep moving through the circuit until it hits the other resistor. That's going to take away some energy. Let's say it takes away 8 joules of energy, because it had 8 volts of difference across it. Now all the energy is used up, and it can't do anything except move back to the battery, where it just rests and it's dead. So to summarize, voltage measures the potential energy of an electric charge. We measure it in volts. Current measures the amount of charge that's moving through a wire, and we measure current in amps. Finally, the voltage drop across an object, it tells you how much energy that object takes away per charge. So the voltage drop through a resistor tells you how much energy gets taken away from the electricity as it moves through the resistor. That was it. I hope it was helpful.